In this video, we are going to look at how we can find the derivatives of radical functions. Now, when we talk of radical functions, they are functions that find themselves under root sign. Now, the root could be square root, it could be cube root, it could be fourth root, fifth root, and so on. So we have here y equals square root of x. Now, from indices, when you have square root of a, the fractional index for square root of a is a to the power half. Now the fractional index for cube root of a, cube roots of a is equal to 1/3, or a to the power 1/3. Now fourth root of a is equal to a to the power 1/4, and then fifth root of a is equal to a to the power 1/5. Now we have here y equals square root of x. So the function can also be written as x to the power half. So x to the power half is the fractional index for square root of x. So how do we differentiate this? So we are differentiating y with respect to x. So that is giving us dy dx. Now to differentiate x to the power half, what we do is that we multiply the exponent of x to the coefficients of x. We multiply the exponent half to the coefficients of x, and the coefficients of x here is 1. So half times 1 gives us half. And then the exponent of the x has to reduce by 1. So half minus 1 is negative half. Good. Now, from our previous lesson, we learned how the exponent of a variable changes when we move from top to bottom and bottom to top. So in this case, dy dx is going to give us half. Now we want to make the coefficients of x squared positive, so we are going to move from top here to the bottom here. So because it has moved from top to the bottom, the exponent negative half will change to positive half. Good. Now remember, we said that square root of a equals to a to the power half. So a to the power half can also be written as square root of a, and vice versa. Therefore, this x to the power half can be written as square root of x. So know that. Therefore, dy dx is equal to 1 over 2 square root of x. Now let's look at another one over here. What is y equals cube root of x? So remember, we said that square root of or cube root of a is equal to a to the power 1/3. So we are using this idea to rewrite our function in its fractional index form. So y is equal to x to the power 1/3. Now once again, we are differentiating y with respect to x. So dy dx is equal to, so differentiating x to the power 1/3, what we do is that we multiply the exponent of the x by the coefficients of x, and you know coefficients of x is 1. So 1/3 times 1 gives us 1/3. Now x. Now as we differentiate x to the power 1/3, the exponent 1/3 has to reduce by 1. So 1/3 minus 1 will give us negative 2 over 3. 2 over 3. So this is the derivative. But then we can also make the exponent of the x positive by moving it from the top to the bottom here, so that the exponent x will change from negative 2 over 3 to positive 2 over 3. Therefore, dy dx is equal to 1 over 3x to the power 1/3. Sorry, 2/3. 2/3. Right. Now, from indices, when you have when you have a to the power n over m, this is equal to a to the power 1 over m n. So applying this over here, we have x to the power 2 on 3. This is the same as, it's like we want to factor the 2 out. So that's going to give us x to the power 3, x to the power 1/3 to the power. So we are bringing the 2 out. So when the 2 is being factored out, what will be left is 1. Alright. And remember, this x to the power 1/3, x to the power 1/3 is the same as cube root of x. So we bring the 2 here, so that's become cube root of x to the power 2. So this is now this. So let's write it here. dy dx is equal to 1 over 3 in brackets cube root of x all squared. So this is the derivative of y equals cube root of x. Thank you. Please don't forget to comment, like, and then subscribe, and you can share as well. Thank you.